Hello everyone. In our last video, we studied about different kind of operators used in Python except the bitwise operator. Because bitwise operator is a bit conceptual. So in this video, I will make you understand bitwise operator from the scratch. Okay. So what is the bitwise operator? Bitwise and, bitwise or, bitwise XOR, bitwise not, left shift and right shift operator. Okay, now let's do some coding. Suppose I want to print 2 and 3. Now let's run it and see what's the output. Here, bitwise AND operation is performed on the binary values of 2 and 3. Okay, let's see. 2 and 3. First, they are converted to binary numbers. These are decimal numbers and it has to be converted to binary number. Now, how? First, we have to divide it by 2. What will be the quotient? 1. And what is the remainder? 0. Now, I have to write in this manner. So, the output will be 1 and 0. This is the binary value of 2. What about 3? Same way, divided it by 2. What will be the quotient? 1. What will be the remainder? 1. So, what will be the output? Same way, 1 and 1. Now, what we have done? Now, we have performed AND operation. What is AND operation? AND operation is it will give output 1 only when both are 1. So, here if we add 0 and 1, here both are not 1, so output will be 0. Here both are 1, 1 and 1, so output will be 1. So, the value is 1 and 0. Binary value of 2. So, the output will be 2. See? Clear? Let's do another example. Suppose 6 and 3. Now 6. Same way, change it to binary value by dividing it by 2, 3. So what is the remainder? 0. Now we again have to divide it by 2 until it becomes 1. Until the quotient becomes 1, we have to continuously divide it by 2. So now the quotient is 1 and what is the remainder? 1. Now we will again do the same procedure. And what will be the output? 1, 1, 0. To perform bitwise AND on 6 and 3. So what is the value of 3? Binary value of 3? 1, 1. So write 1, 1. And this is nothing but 0. Okay. Now perform AND operation. Now I said that it will give output as 1 only when both are 1. So here it will be 0, but here it will be 1 and again it will be 0. Now what is the decimal value of 010? How to calculate that? Let's see how to do that. This is in 0th position. This is in first position. This is in second position. Okay. So now what we have to do? We have to take the first value, that is 0, into, or we can say we have to multiply it with 2 to the power the position of the number, that is 0, plus second value is 1, so 1 into 2 to the power position 1 plus 0 into 2 to the power 2. Now if we add this, what will happen? This is 0, this is 0, this will be 0. Now the answer is 2. Now let's run it. See, this is true. So this is how bitwise AND operation is performed. I hope now this is clear. The next one is bitwise OR. How can we do that? We print 2, 3. This is the symbol of bitwise OR. Okay. Now let's first do it. Then we will run it. We know the value of 2, 1 and 0. If you don't know, you can just calculate it the way I have shown you. 1, 0. Next one we have used 3. What is the value of 3? Binary value of 3? 1, 1. So it will be 1 and 1. Now what is OR operation? In OR operation, output will be 1 whenever at least one value is 1. Okay. So here 0, 1, it will be 1 because at least one of them is 1. Here same, one of them is at least one of them is 1. So output will be 1. Now what will be the binary value of this 1, 1? Let's do with same procedure. This will be 0. This will be 1. Now 1 into 2 to the power position value 0 plus 1 into 2 to the power position value 1. So what will be the output? 2 to the power 0, 1. So this will be 1 plus 2 equals to 3. Let's see. Run it. Clear? So you can try some other examples also. First, what you have to do is to change the decimal value to its binary form, then perform the operations and or whatever you want to wish. Then you can again convert it to the decimal value and you can check it from here. So this is how it is working. Okay. But Python has all built-in functions, so you don't have to perform this manually. You just can see how Python is doing these operations. Now, what is bitwise JOR? The symbol for bitwise JOR is this one. Binary value of 2 is 1, 0. Binary value of 3. In JOR function, the output will be 1 if the inputs are different. But the output will be 0 if the inputs are same. Okay. So if the inputs are 0, 0, output will be 0. If the inputs are 1 and 1, output will be 0. But if the inputs are 0, 1 or 1, 0, the output will be 1. So now what will be the decimal value? Same way, we have to write 1 into, you can do it by your own, 2 to the power 0 plus 0 into 2 to the power 1. Once you become pro, you will not calculate this 0 because it will be 0 only. But for now, you can write all the things. Now, what will be the output? 1. So, let's run it. Okay. Try with some other examples. Now, what is bitwise not? Now, bitwise not 3. What is the binary value? Same way, we already calculated. So, it is 1, 1. Okay. Now, to do the bitwise operation, you have to follow some steps. First, you have to make it 8 digit, 6 zeros and the 2 1. So it has become an 8 digit. Now we have to inverse, like 0 will be 1 and 1 will be 0. This is the second step. 0, 0. Fine. Now the first one is used for sign. When it is 0, this is positive. When it is 1, this means it is negative number. Okay, okay. So this is done to check the number is positive or negative. If the leftmost value is 0, it is a positive number. If it is 1, it is a negative number. Okay. Now the next step is with the previous number like 0, 1, add 1. Now if you don't know how to add, I will just tell in short. Perform additional operation in binary. There are some rules. Suppose we want to add 0 plus 0. Then the output will be 0 and there will be no carry. Next, if we add 0 plus 1, the output will be 1. Will carry nothing. If the number 1 is added with 0, same the output will be 1. And if 1 plus 1, then the output will be 1, but then the output will be 0, but there will be a carryover which will be 1. Okay, now let's add it here. 1 plus 1, I said the output will be 0, but 1 will be the carry and it will be added to the next number. Okay, again we have to add 1 plus 1, that is 0. Similar way, there will be again a carry of 1. Next 1 plus 0, 1 plus 0. So the output will be 1 and no carry. So here there is nothing, this is a 0, output will be 0. So the output is 100, decimal number. So 100 equals to 1 into, you can say this is the 0th position, this is 1, this is second position. So 1 into 2 to the power of 0. I'm so sorry, this will be 0. This will be 0 into 2 to the power of 0 plus again 0 into 2 to the power of 1 plus 1 into 2 to the power of 2. 2 is the position. So what will be the output? This is 0, this is 0, it will be 4. So the output will be 4. And the output will not be positive 4. We have already calculated the sign, so the output will be minus 4. Okay, so what are the steps? We will summarize here. First, run it, minus 4. Clear? First, convert the binary, the decimal value to a binary value. Second, invert the number. Not means invert the number to calculate its symbol. Now, add 1 with the binary value of the number. Okay, binary value of 8 digits. Okay, now we have to do calculate the decimal value of the result. Okay, this is simple, but you have to follow some steps. Okay, now we will understand what is right shift operator. Print 4, right shift 2. What will be the output? 1. Now how? Let's see how. First 4, we have to convert it to a decimal number, to a binary number. So this will be 0. Again we have to divide with 2. So the quotient will be 1, output will be, remainder will be 0. So again following the same procedure, we can say the binary value of 4 is 100. Okay. Now what do you mean by right shift? Right shift means you have to delete the rightmost two numbers. So 0 and 0 will be deleted. Only 1 will be the output. Let's see the output. This is 1. Clear? If you want, I can do one more for you. Print 6, 2. Let's see. First, we will calculate. Okay. 6 divided it by 2. The quotient will be 3. Remainder will be 0. Again divide by 2. 1. The remainder will be 1. Again the output will be 1 because what will happen? The last two element will the last two digit will be deleted, so the value will be 1. Let's check. Let's take a big number so that we get a different output. Let's do this one, 12. Now you tell me how to calculate. Now I think you have become a pro. Q, this will be quotient will be 6, remainder will be 0. Again the quotient will be 3, the remainder will be 0. Again it will be 1, the remainder will be 1. So the output is 1100. Clear? Now for right shift you have to delete the rightmost two digits. This will be deleted. Output will be 1 1. Now convert it to again in decimal number. So 1 into 2 to the power 0 plus 1 into 2 to the power 1. Calculate it. 1 plus 2. The output will be 3. Right? Okay. Now let's run it. Clear? So we have understood bitwise right shift. And the last one is bitwise left shift. In left shift operator, two zeros are added in the right. Okay. Now if I calculate it, this is 0 position, this is 1, this is 2, this is 3, this is 4. The decimal value will be 0 into 2 to the power 0 plus 0 into 2 to the power 1 plus 0 into 2 to the power 2 plus 0 into 2 to the power 3 plus 1 into 2 to the power 4. So if we calculate, the output will be 16. This is what left shift operator does. Now let's run it. Clear? So you can take other numbers and perform these operations. These are all about bitwise operator. In data science field, these are not so much used or dominated. Maybe you can get in some computer vision or image processing applications, but in low level programming languages, these are mainly used, not in data science. But still, if you want to understand things in depth, you can do your some own research. This is the main concept behind this bitwise operator. When you learn something in depth, you feel good. Okay. Okay, let's meet in our next video. Till then, bye.